Hi, my name is Adyasha and I'm a fourth-year PhD student at UNC Chapel Hill, advised by Professor Mohit Bansal. I'm excited to present our work on multimodal intent discovery from Livestream videos. Video tutorials are one of the most common sources of instructions today, but identification of procedural intent remains largely unexplored. This is an example of frames from an Adobe Photoshop tutorial. The phrases in pink and blue are examples of intents that we want to extract and which can be a potentially useful resource for tasks like video summarization, search, and recommendation. But existing datasets fall short of this fine-grained intent extraction task. Hence, in this work, we introduce the problem of instructional intent identification and extraction from software instructional live streams. We present a new multimodal dataset consisting of software instructional live streams, that is the Behance Livestream corpus, and manual annotations for both detailed and abstract procedural intent, that is the Behance Intent Discovery dataset. We first obtained 2,049 videos containing nearly 5,000 hours of video instructions, along with their transcripts and tool timelines from the Behance platform. These videos are created by artists who demonstrate the use of various Adobe softwares while sharing their screen. Next, we prepare annotations for extracting intents from the transcripts. An intent is a text phrase containing an action, which is a definite task, goal, or activity, and an object that the action is going to act or operate upon. We identified two major categories of meaningful intent. The tool intents are low-level intents, and the creative intents are abstract intents used to describe a high-level creative goal. We frame this task as a sequence tagging problem. Each sample contains a sentence with IOB span annotations for either of the classes. We recruited 2 annotators using the Upwork crowdsourcing platform to create these annotations. The resulting dataset contains 20,000 samples. We performed an analysis of the top nouns and verbs present in each of the intent classes. Tool intents contain definite actions such as merge, select, add, delete, etc., while the creative intents contain abstract and subjective visual concepts which pose a unique and interesting challenge to multimodal models. In order to perform this task, we trained a series of models for the joint prediction of both tool and creative intents from this dataset. First, we run the text-only baselines. The text encoder is used to extract encodings, which are then passed to the classifier layer for computing tag probabilities. Next, we attempt to fuse video embeddings with the text encodings from language models in a naive manner through a single cross-attention layer as shown in the figure. Analysis of the results from this model reveals that the textual features dominate the final decision, and naive fusion does not improve significantly beyond text-only baselines. To further investigate the situation, we performed a pilot task in which a human annotator looks through the video segments and tries to guess the intent without any transcript or audio. Our pilot task revealed that the video signal is much more ambiguous than the discriminative text signal and cannot be used to distinguish tool versus creative intent. But also importantly, the video signal is good at identifying whether an intent is present or not. So from the pilot study, we built the intuition that the text signal provides candidates for the vision model, which is subsequently used for filtering out the cases without intent. Based on this, we designed the cascaded cross-attention model with late fusion of text and video. As seen in the figure, the video encodings are passed through a series of cross-attention layers along with the text encodings to produce contextualized video embeddings. These contextualized embeddings are then used to dynamically compute a visual gate in order to regulate the contribution of video embedding to the final prediction. We use this late fusion framework with unimodal Roberta and multimodal hero and clipboard models. Among text baselines, we see the best performance from the Roberta models. Notably, the tool intent predictor is biased with high recall but low precision performance. The naive fusion approach with pre-trained Roberta yields small improvement over the text-only baselines. But compared to the naive fusion models, the late fusion models improve precision for tool intents, reinforcing our hypothesis about the weaker video signal and the discriminative text signal. The slow-fast representations with Roberta prove especially beneficial for creative intents. Finally, for multimodal pre-trained models, Hero uses video representations from pre-trained encoders, while Clipboard operates on raw videos. Both approaches work well with the software-based video domain, and larger improvements are seen from further augmenting these models with late fusion. To understand how the video signal helps the prediction, we plot the mean and standard deviation of visual gate values. Our results show that the visual gate preferentially relies on the video modality for tokens outside the intent span. In summary, we explore the novel task of video-based multimodal intent discovery. We present the unlabeled Behance Livestream corpus and the Behance Intent Discovery dataset for this purpose. We propose a late fusion approach for integration of the video signal with the text signal and show significant improvements with both unimodal and multimodal pre-trained models. Please read our paper for more details. Thank you.